The story of everything may be missing its first page, and that single idea quietly shakes the foundation of what most people believe about reality. For decades, the Big Bang has been presented as the ultimate starting point, the moment when space, time, matter, and energy suddenly appeared. But modern science now hints at a deeper truth, one that feels unsettling and fascinating at the same time. The Big Bang may not be the beginning at all. It may be only a chapter in a much longer cosmic story, a visible event that hides something far older beneath it. In this video, we are going to explore why some of the world's top scientists no longer see the Big Bang as the first moment of existence, what serious problems exist inside the theory itself, and how new ideas suggest the universe could be eternal, cyclic, or part of something far larger than we can see. We will uncover lesser-known facts that rarely appear in textbooks, including why the laws of physics fail when pushed back to the so-called beginning, why time itself becomes unstable in our equations, and why some evidence points to events that may have happened before the universe began expanding. This is not science fiction, and it is not speculation without support. These ideas come from real physics, real observations, and real debates happening right now among cosmologists. By the end of this video, you will understand why asking about the beginning of everything might be the wrong question, why the word beginning itself could be misleading, and how our universe might be just one phase in an endless process of change. You will also see how discoveries in cosmic background radiation, gravity, and quantum physics are slowly peeling back the curtain on what came before the Big Bang, even if the full answer remains hidden. This journey matters because it reshapes how we see existence, time, and our place in the universe. If the universe never truly began, then reality is far older and deeper than we were taught, and that changes everything. Stay with us until the end, because the final idea may completely alter how you think about time and origins. Welcome to our channel, where we explore the biggest questions science dares to ask. If you enjoy videos that challenge common beliefs and dive into the mysteries of the universe, make sure to subscribe and join us as we search for answers beyond the edge of the known cosmos. For most people, the story of the universe feels settled and clear. The Big Bang is taught as a solid fact, almost like a historical event that has already been fully understood. According to this widely accepted idea, the universe began about 13.8 billion years ago in an extremely hot and dense state. Everything that exists today, every galaxy, every star, every atom, was once packed together in a space far smaller than we can easily imagine. Then expansion began. Space itself started stretching, carrying matter and energy outward in all directions. This expansion did not happen into empty space, because there was no space yet. Space was being created as it expanded. Over time, the universe cooled. Simple particles formed first, then atoms, then clouds of gas, then stars and galaxies. Even today, this expansion continues. When astronomers look at distant galaxies, they see that almost all of them are moving away from us. The farther away they are, the faster they appear to be receding. This pattern is one of the strongest pieces of evidence supporting the Big Bang model. Another key piece of evidence comes from faint radiation that fills the entire universe. This radiation is uniform and cold, and it is understood as the leftover heat from the early universe, a kind of cosmic afterglow from a time when everything was once much hotter and closer together. Together, these observations form the backbone of modern cosmology. They explain why the universe looks the way it does on large scales and why it has a clear history of change. The Big Bang theory successfully describes how the universe evolved from an early hot state into the complex structure we see today. It explains galaxy formation, element creation, and large-scale cosmic patterns with remarkable accuracy. Because of this success, it has become the dominant explanation taught in schools, shown in documentaries, and repeated in popular science. Yet, beneath this confident picture lies an important limitation that is often overlooked. The Big Bang theory describes what happened after the universe began expanding, but it does not fully explain why that expansion started in the first place. When scientists trace the equations of the universe backward in time, they eventually reach a point where density and temperature rise without limit. This point is known as the singularity. At the singularity, the known laws of physics stop working. Gravity becomes infinitely strong. Space and time lose their usual meaning. The equations no longer produce sensible results. Instead of clear answers, they return infinities, which in physics usually signal that a theory has reached its breaking point. This is where the idea of a clear beginning becomes problematic. If physics cannot describe what happens at this moment, then calling it a true beginning may be misleading. The Big Bang in this sense is not a complete explanation of origins. It is a boundary beyond which our current understanding cannot pass. Scientists openly acknowledge this issue. The theory works incredibly well for describing the universe once it is already expanding, but it remains silent about the cause of that expansion. There is no explanation within the theory itself for why the universe existed in such a dense state, or what set the expansion into motion. The problem becomes even deeper when time itself is examined more closely. In everyday experience, time feels continuous and absolute. There is always a before and an after. But near the supposed beginning of the universe, this intuition breaks down. According to general relativity, time is woven together with space into a single structure. When space is compressed into an infinitely small point, time may also lose its independent meaning. This raises a disturbing possibility. If time itself becomes undefined at the singularity, then asking what happened before the Big Bang may not make sense in the usual way. The word before assumes that time was already flowing. But if time emerged along with space during the expansion, then there may be no earlier moment to point to. This creates a logical gap. The Big Bang is often described as the beginning of time, yet it is also treated as an event that happened in time. These two ideas conflict with each other. If time began at the Big Bang, then it cannot be something that happened after something else. This tension reveals that the concept of a beginning is not as simple as it sounds. Because of these unresolved issues, some scientists have explored alternatives that remove the idea of a beginning altogether. One such idea is the steady-state model. This theory proposes that the universe has always existed and will always exist in roughly the same large-scale form. According to this view, the universe is expanding, but new matter is continuously created as space grows, keeping the overall density constant. There is no starting point and no final end. Time stretches infinitely into the past and the future. The universe simply is. This idea was once taken seriously and even competed with the Big Bang model for many years. It appealed to those who found the concept of a sudden creation event unsatisfying. In a steady-state universe, there is no special moment of origin. The laws of physics remain the same everywhere and at all times. The universe looks statistically similar no matter when it is observed. While later observations challenged this model and led most scientists to favor the Big Bang framework, the steady-state idea remains important for one reason. It shows that the concept of an eternal universe is not outside scientific thinking. It demonstrates that a universe without a beginning is a logical possibility, not just a philosophical idea. Another approach to avoiding a singular beginning comes from cyclic models of the universe. In these models, the universe does not begin once and end once. Instead, it goes through repeated phases of expansion and contraction. The universe grows large, cools, and spreads out. Then, under certain conditions, expansion slows, stops, and reverses. Space begins to shrink. Matter draws closer together. The universe heats up again as it contracts. Eventually, instead of collapsing into a singularity, the contraction halts and reverses into a new expansion. This transition is known as a bounce. Each bounce marks the start of a new expanding phase, similar to what we call the Big Bang. In this picture, our Big Bang is not the first one. It is simply the most recent bounce in a long sequence of cosmic cycles. There may have been many universes before ours, each leaving subtle imprints on the next time. In this model, does not have a true beginning. It extends through countless cycles, each one connected to the next. The idea of a cyclic universe addresses several deep problems. It removes the need for a singularity where physics breaks down. Instead of infinite density, there is a minimum size and maximum temperature that the universe reaches before bouncing back. This allows known or extended laws of physics to remain valid at all times. It also offers possible explanations for why the universe appears so uniform on large scales. Conditions from a previous cycle could smooth out irregularities before the next expansion begins. While these models are complex and still under development, they are based on serious mathematical work and are actively studied by physicists. They suggest that what we call the beginning may actually be a transition, not a creation from nothing. In these cyclic views, the word beginning becomes a matter of perspective rather than an absolute fact. From within a single expansion phase, it looks like everything started at one moment. But from a broader viewpoint, that moment is just a turning point in an ongoing process. This challenges deeply held assumptions about time and existence. It suggests that the universe may not have emerged suddenly, but evolved through stages far older than our observable history. Each cycle may erase most traces of the one before it, making direct evidence difficult to find. Still, subtle signals could remain, encoded in the structure of space, or in faint patterns left over from earlier eras. As these ideas show, the Big Bang Theory, powerful as it is, may describe only part of the universe's story. It tells us how the universe expanded and cooled, but it may not tell us how existence itself began, or even whether it began at all. The concept of a beginning becomes less certain the closer science looks at it. The more deeply physicists explore the foundations of space and time, the more the idea of a single starting point starts to blur. What once seemed like a clear origin now appears more like a boundary of knowledge, a line beyond which new ideas are required. The universe, instead of having a simple birth moment, may have a history far richer and stranger than the word beginning can capture. Beyond the familiar picture of a hot, dense beginning, some theories push the origin of the universe into dimensions we cannot see. One of the most striking ideas comes from what is known as the ekpyrotic universe. In this view, our universe did not emerge from a singular point of infinite density. Instead, it was born from a violent interaction in a higher dimensional space. Reality, according to this idea, includes more dimensions than the three of space and one of time that we experience. Within this larger space exist vast surfaces called branes. Our entire universe may be confined to one such brane, while another brane exists nearby, invisible and unreachable. Over immense periods, these branes move slowly through the higher dimensional space. Eventually, they collide. That collision releases enormous energy and heat, creating conditions that look very similar to what we call the Big Bang. In this picture, the Big Bang is not a true beginning. It is a transition, a moment of change from one state of the universe to another. Space and matter already existed in some form before the collision. The universe did not come from nothing. It was reshaped. Time did not suddenly appear. It continued through the event. What we perceive as the start of everything is simply the aftermath of a cosmic impact far beyond our senses. This idea avoids the problem of a singularity entirely. There is no point where physics collapses into infinity. Instead, there is motion, interaction, and transformation. The universe has a past that extends beyond the hot expansion phase we observe today, even if that past is hidden behind dimensions we cannot directly detect. Closely connected to this is the idea that our universe may not be unique at all. Some cosmologists propose that what we call the universe is only a small region within a much larger structure known as the multiverse. In this framework, space itself is constantly undergoing a process called eternal inflation. Certain regions stop inflating and form bubble universes like ours, while other regions continue expanding at an enormous rate. Each bubble becomes its own universe with its own space, time, and physical conditions. Our Big Bang, from this perspective, was simply the birth of one such bubble. It was not the birth of everything. Other bubbles may have formed long before ours, and many more may form long after. Some could have different physical laws, different constants, and entirely different histories. The larger structure never stops. Inflation continues endlessly, spawning universes again and again. This means existence itself may have no overall beginning. There is always some region inflating, always some universe forming. Our cosmic history becomes local rather than absolute. The Big Bang marks the start of our observable region, not the start of reality as a whole. This idea changes the meaning of origins. Instead of asking how everything began, the question becomes how our particular universe formed within a much larger and older process. These ideas lead to a deeper and more unsettling issue. The concept of before the Big Bang may itself be flawed. In everyday language, before is tied to time. But if time is not fundamental, then the question loses its meaning. Some theories suggest that time emerged along with space during the expansion of the universe. In such models, time does not exist independently in the background. It is a property of the universe itself. When the universe changes, time exists. When there is no universe in the familiar sense, time has no definition. This means there may be no earlier moment to point to. There is no empty timeline waiting for the universe to appear. The appearance of time and the appearance of the expanding universe are the same event. Asking what happened before becomes like asking what is north of the North Pole. The question assumes a direction that no longer applies. This idea is deeply counterintuitive, yet it emerges naturally from attempts to combine gravity with quantum physics. Near the conditions associated with the Big Bang, space and time may blur into something more fundamental, something that does not follow the rules of cause and effect as we understand them. In that realm, familiar concepts like earlier and later may simply dissolve. Even with all these theories, science has not given up on searching for concrete evidence. Modern cosmology is driven by observation as much as by mathematics. Scientists are carefully studying the cosmic microwave background, the faint radiation that fills the universe. Tiny patterns in this radiation may contain information about processes that happened before the hot expansion phase. Unusual alignments, temperature variations, or subtle asymmetries could hint at earlier cosmic events, collisions with other universes, or remnants of previous cycles. Gravitational waves offer another promising window. These ripples in space itself can travel through the universe almost unchanged, carrying information from extremely early times. Certain types of gravitational waves could reveal signs of a bounce, a brane collision, or inflationary processes that occurred before our universe settled into its current form. New detectors are being built to listen for these signals with unprecedented sensitivity. At the same time, physicists are developing deeper theories that aim to unite gravity and quantum mechanics into a single framework. Such a theory may finally describe what happens when density and energy reach extreme levels, removing the need for singularities altogether. As these investigations continue, the picture of the Big Bang grows more complex and less final. It begins to look less like the first moment of existence and more like a doorway between deeper layers of reality. Each new idea shifts the boundary of the unknown rather than erasing it. The universe may extend further into the past than we can currently observe, or it may exist within a structure so vast that our entire cosmic history is only a small fragment of a much greater process. The search is ongoing, driven by the hope that traces of these deeper origins are still written into the fabric of space itself, waiting to be recognized and understood. The deeper science looks, the more the idea of a single absolute beginning starts to fade. The Big Bang still stands as one of the most powerful explanations we have, but it may not be the first moment of everything, only the earliest chapter we can currently read. Beyond it could lie earlier states of the universe, hidden dimensions, endless cycles, or realities far larger than our own. The truth is, the universe is under no obligation to match our expectations of how a beginning should look. What feels like an origin to us may simply be a transition, a turning point in a story that stretches far beyond human timescales. One day, new discoveries may reveal whether time itself had a first moment or whether existence has always been unfolding in different forms. Until then, the question remains open, waiting at the edge of knowledge. And if the universe never truly began, if there was no first moment at all, then our place within it becomes even more profound. We are not just living after the beginning of everything. We are part of an endless process, a small but meaningful expression of something far older and deeper than we can imagine. If this idea sparked your curiosity, make sure to like this video, share it with others who love exploring big questions, and subscribe to the channel for more journeys into the mysteries of the universe.